In the last video, we talked about how to use the inverse normal function call to help us find boundary values when we know the probability or area under the curve in a normal distribution. Well, remember when we talked about measures of location in our first week, one of those measures of location was called a percentile. And we know that percentiles are values that divide a data set or distribution into 100 equal count chunks. The most important part of that is they are data values. And they are data values that correspond with a percent measure. Right? 80th percentile. That means 80% of the data values are less than or equal to that x value. These are very similar to the problems we saw in the last video, except they are all left tail questions. So we're going to use the same step list we used in our last video to find percentiles. So we're going to do a couple examples together so you can see what this modified process looks like. So our first example says, in the United States, the ages 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36.9 years and 13.9 years respectively. Using the information, answer the following questions, round answers to one decimal place. Calculate the interquartile range. 40% of the smartphone users from 13 to 55 plus are at least what age? So let's go through that problem and check what we know. So it says the ages approximately follow a normal distribution. They give us a mean of 36.9 years and a standard deviation of 13.9 years. And then we're asked a couple of questions. First, we're asked to calculate the interquartile range. And next, we're asked for an age, given that 40% of smartphone users are at least that age. Meaning we're given percent, or probability, or area under the curve, and we're asked for boundary values. Let's start with A. For A, I know that the interquartile range is equal to Q3 minus Q1. So I have two options here. I could find the third quartile and the first quartile separately. The other thing that I happen to know is that the interquartile range should be the middle 50% of data. Oops. So I can find the quartile separately. I can find the middle 50%. Either way, I'm going to get the same answer. I'm going to find those quartiles separately because ultimately to find the middle 50%, I have to find those two boundaries separately anyway. So for A, let's go ahead and start with our picture. We'll label it, and then we'll start solving. So we know that our mean is 36.9 years, and then we're going to go out 3 standard deviations in either direction. So 36.9, and then I'm adding 13.9. Ooh. That makes more sense. So 50.8, 64.7, and 78.6. And then in the other direction, 36.9 minus 13.9. And we get 23, 9.1, and negative 4.8. I'm looking for two different boundary values. I'm looking for quartile 3, which I'm going to mark in red, and that's the 75% marker. And I know from previous problems that that sits somewhere between the mean and the first standard deviation. So I expect that Q3 sits right here, and that's 75% of the data less than. And then I'm going to do the next one, Q1 in orange. I know that also sits within one standard deviation, and that 25% of the data is less than the first quartile. When I do this on my calculator, remember that I'm not looking for Q3 and Q1 separately. I'm looking for the IQR. So what I really want is Q3 minus Q1. So I'm going to do these inverse normal calls one after the other. So I'm going to do inverse norm for Q3 first. Area to the left is 0.75. Mean is 36.9. Standard deviation is 13.9. And then minus, and then I'm going to do the inverse norm call for Q1, which is 0.25. 36.9, 13.9. So second vars, option 3, and we're just going to fill that data in. And then minus, and then I'm going to go back to second vars and do that function call over again with a different area. And you'll notice the mean and standard deviation are still there, so I can go straight down to paste after changing that area. So our interquartile range is 18.75. And that makes sense looking at our picture because I can see that I'm subtracting a number that's about 25-ish from a number that's 40-something. So I should get something that is about 20-something. So this makes sense in terms of where those two sit in my picture. Let's go ahead and try the next question, which says 40% of smartphone users from 13 to 55 plus are at least what age? We know that at least means greater than or equal to. So this question for B is a right tail question. So when we go to draw our picture, that 40% tail is going to go in the right side of the picture. So we know what those numbers are. We have them from the previous picture. And I want 40%, so I expect that I'm sitting about here, somewhere slightly more than the 50% marker, which is my mean or my median. the area that I'm looking at in the picture is this area here. And I know that that area represents 40% of cell phone users in that range. So I'm looking for that boundary. Remember that on my calculator, I don't want area to the right, I want area to the left. And if the whole curve's 100%, 100 minus 40 is 60%. So that is the number I'm plugging into my inverse norm function call. So that boundary marker, which also represents the 60th percentile, is going to be inverse norm 0.6, and then the same mean and standard deviation we've been using because it's the same distribution, the same random variable. And we get 40.4. And we can see that that sits where we thought it does. It sits between the mean, or median, and that one standard deviation above the mean. All right, if you have any questions on how to find data values or percentiles in a normal distribution, feel free to send me an email or drop by office hours on Tuesday or Thursday. Otherwise, I'll see you in our next video.